strong acids, weak acids, what's the difference? Well, strong acid, let's take the HX. HX, it's got H in it, okay, which makes it an acid. All acids have got H hydrogen in. The difference between a strong acid and a weak acid is that if you were to take 100 or 1,000 or whatever number of these acid molecules, dissolve them in water, then every single one of them would dissociate into a H plus proton. You'd have 100 of them, and you would have 100 of these. So you get complete dissociation with a strong acid. Weak acid, on the other hand, take a HX again. What happens this time is that there's only partial dissociation, so only some of the H's will drop off, and you'll only have a fraction. So, for example, for every 100, just for example, say you might have, I don't know, 20 of them and 20 of them. You would not have complete dissociation like this one. Example of a strong acid, HCl. You would produce the H plus and the Cl minus. Example of a weak acid, ethanoic acid, COOH. Well, the H that is able to go, or is able to dissociate, is this one here. These are never lost. They're just too strongly held onto. This is the bond that breaks, and what you form is CH3 COO minus and an X minus. Now, as well as that, it's also a reversible reaction, so we should have a double-headed arrow here and a double-headed arrow here. So because this is a reversible reaction, we can then look at the equilibrium constant for this reaction, which would be, if we take this general one here, would be Kc is equal to the product over the reactants, so the concentration of H plus times by the concentration of X minus divided by the concentration of the reactant, which is HX. But now we are talking specifically about weak acids, so we don't refer to the Kc of the weak acid, we refer to the Ka, A for the equilibrium constant for an acid, and that's the equation that we use.